Hey everyone! Welcome to online 6B Algebra. So today the plan is to go over the quiz from last week. I'll be doing most of the questions and I'm going to leave some questions undone so that you guys can do them for homework. So last week I thought the quiz was really hard. And maybe some of you guys agree. I thought it was pretty challenging, but there's still lots to be learned from it, which is why I'm spending this time to go over it and to have you guys try the problems on your own. I know a lot of you also missed the quiz. I'm still thinking about whether or not to even count it. I'm leaning towards not counting the quiz towards the grade. But the important thing, honestly, is that everybody learns something from the quiz, and we are all familiar with exponents before we keep moving on. Okay, so let's just, before starting the quiz, review the exponent facts that we need. So I think the exponent half of the quiz was a lot harder than the rational numbers and absolute value half. So let's just start, it's a little big. Let's start with a recap of exponent facts. Awesome. So we first start with the definition of an exponent. We have the base, a, and n is also called the exponent. This just means that the number a is going to be multiplied to itself a total of n times. And using this definition, we actually can just deduce a lot of the facts right off the bat. So first of all, if I have a to the m times a to the n, if I use the definition, a to the m involves taking a and multiplying it to itself m times. And a to the n involves taking a and multiplying it to itself n times. If we combine all of the a's together, we actually get m plus n of them. So this is how we know that this is equal to a to the m plus n. Similarly, we can think about what happens when we divide exponents. So let's say we have a to the m divided by a to the n. So actually here, there are two different things that could happen. And it depends on how big m and n are relative to each other. So in the first case, let's say m is at least the size of n, so it's bigger than or equal to n. If we use our definition again, we have a multiplied to itself m times, and we have a multiplied to itself n times in the denominator. So now life is good because we have the same factors in both the numerator and the denominator. So we can cancel out factors of a from both. Well, so because m is at least the size of n, we're going to be canceling everything in the denominator before we necessarily cancel everything in the numerator. So we're going to have a bunch of a's left over in the numerator. Turns out that there are exactly m minus n a's left over. In the case where m equals n, we get a to the 0 in this term over here. And that checks out because that means we started with a fraction whose numerator and denominator were the same, and that is 1. So now the only other thing to worry about is the case where n is smaller than m. So again, I can start with my definition. We have m of these on the top. Let me just move things around to make it a bit more organized. And we have n things on the bottom. We can play the game of canceling again. But because m is smaller than n, the a's on the top will finish canceling before the a's on the bottom. So in the numerator, we're just left with 1 at the end. And in the denominator now, we have a to the n minus m. So yeah, this fact is a little bit tricky because we have the two cases. I also got a lot of questions about this fact during the quiz. So if I have a to the m and I raise this whole thing to the n, I don't add the exponents. I have to multiply the exponents. And I'll leave it as an exercise for you guys to try to figure out why this is true. Again, you can just use the definition. And lastly, there are these two facts that might just be helpful in terms of for us to simplify things. So if I have the number a times b and I raise the whole thing to the n, I'll actually get a to the n, a to the n times b to the n. And similarly, if I have a over b, all raised to the n, I get a to the n divided by b to the n. Okay, I think with this review, we can now jump into the quiz. Okay, so let's start with page 1. I think page 1 was the most challenging part. And this is because the questions are all multi-step. But I want to go through each question slowly to show that we can do it if we stay organized. We can avoid mistakes by doing things one fact at a time. So in today's video, I'll be doing questions 1 and 3. I'm going to be leaving questions 2 and 4 for homework. And I'll give you guys some hints and tips on how to work them out. Okay, so first with question 1. As I said before, the key is to try to simplify things one fact at a time. This will make it harder for us to make mistakes. So taking a look at this expression over here, the first thing I see that can be simplified is this x to the 4th times x to the 5th hanging out inside the parentheses. So I'm going to deal with that first. So I have now 3 times x to the 9th, since we have to add 4 and 5. Still square the whole thing, and we're multiplying it to x to the 6th divided by 3 to the 4th. At this point, I can also replace 3 to the 4th with 81, but I don't want to do that just yet because we have more factors of 3 hanging around, and I can try to cancel things out. So I'm going to leave the 3 to the 4 for now. So the next thing so this is the first simplification. The next thing I want to simplify is this over here, where we're raising this whole quantity squared. So now we want to use the fact that a times b to the n is equal to a to the n times b to the n. We have 3 squared times x to the 9 whole thing squared, now times x to the 6 divided by 3 to the 4th. Here there are a variety of things we can try to simplify now. I can try to do 2 simple ones in one step. So first of all, 3 squared, this is equal to 3 times 3. And 3 to the 4th is equal to 3 multiplied to itself 4 times. Since we have factors of 3 now in the numerator and the denominator, we can cancel them out. So let's just clean that up a bit. Now we have x to the 9 whole thing squared times x to the 6 divided by 3 squared. Actually, I'll rewrite it as 3 times 3. At this point, there are no more 3's. I don't have to worry about simplifying 3's anymore, so I'm just going to combine those into a 9. And now we can try to simplify this guy. So this gets us x to the 18th. Remember, we multiply the exponents in this case. And the final answer that we have is x to the 24th divided by 9. So again, the problem might have looked really intimidating at first, but we were able to do this in maybe around 4 or 5 pretty straightforward steps, and this makes it easier to be correct. So for number 2, again, I'm assigning it for homework, but we're going to use the same general principles. So first, the first tip I'll give is to try to simplify this one step at a time. And the general rule of thumb is one fact per step. Again, it's not a hard rule, but this will definitely prevent a lot of errors. Another tip I would like to give is to cancel terms from the numerator and the denominator whenever you can. So this will make your life a lot simpler. But in general, I think you're less likely to make mistakes when you have something like this. Where it's a straightforward base and exponent. I would avoid trying to cancel stuff when it looks like this. For this one, I would simplify first, and then cancel. Okay. So let that sink in for a second. We're going to apply these two principles to number 3 as well. Number 3 is really no different from number 1 and 2, except at the very end, we have to plug in some numbers. And if you guys remember, during the quiz, I gave the hint to simplify this whole thing first and then plug in numbers. So that's exactly what we're going to do. Okay, so first, I'm going to start off with 2, and I'm going to deal with this simplification first. I get x to the 8th. And actually, I'll just do the whole numerator at the same time. I have, actually, no, I'll hold on to it. Okay, in the next step, I actually want to do the x's. So I get 2x to the 8th, y squared times y9. So to simplify these, the x cubed, I have to multiply the exponent. So I get x to the 9th times, this doesn't change. And at this point, I can start canceling x's. So on the top, we have x times x, so on 8 times. And in the denominator, we have x times x times x 9 times. So if we cancel them, we're going to end up with no more x's in the numerator, but a single x in the denominator. Awesome. So now we can deal with the y's. I'm first going to do the numerator. 2y11. I still have my x. And I'll simplify this right now as well. X times y to the 10th. So again, we can cancel the y's because I have 11 of these on the top. And I have 10 of these on the bottom. This tells us, okay, we're going to end up with a single y left over in the numerator, but there are no more y's in the denominator. So now I have the expression 2y divided by x. The last thing we need to do is now plug in the numbers. So we're almost done, which I shouldn't have circled it just yet. Now I want to do 2 times 5 divided by 1/2. But when you're dividing by the fraction, you're actually multiplying by its reciprocal. So this is actually 2 times 5 times 2, which is equal to 20. So this gives us our answer to number 3. So the bonus, I'm making it required homework here. I'll give a hint for the bonus though. we want to use the distributed property. And we want to pull out a common factor. What factor is it going to be? Well, let's look at each of these terms. This term has a prime factor of 5 and a whole bunch of 3's, 7 3's specifically. This next one has a factor of 2 and 9 3's, and here we have 2 2's and 7 3's. The biggest common factor that they all have is 3 to the 7. So give that a try. Alright, I'll let the video pause on this page for a second. Alright, great. So the next page, I'll be doing this one in the video, and I'm going to leave these two to do for homework. And I'll give hints again. So for this first question, I already gave a hint. First, solve for x cubed. So I'll at least do that. I'm going to subtract 3 from both sides, leaving me with 2x cubed is equal to 2662. I want to solve for x cubed. I want to pretend that this is all one variable. And then deal with the cube later. So now if I divide both sides by 2, I get x cubed is equal to 1331. And at this point, this looks like an equation that we know how to do from the textbook. So now we can figure out what x is. And remember, to solve equations like this, we needed to prime factor 1331. So I'll leave that for you to do. We'll do the next question in full. So in this question, when we first look at it, it looks a bit confusing because not too many things share the same base. We have some 3's running around here. We have a 12 and a 4. We have a 6 and a 2. Seems like nothing's in common. But actually, this one you can get really far by just applying PEMDAS. Remember, PEMDAS says we want to do parentheses first. Okay? So if we do the parentheses first, we actually do 6 over 2 first. Simplify that, we get 3. And similarly, if we take 12 over 4, 12 divided by 4 is also 3. This is starting to look great because now we have a bunch of exponents and all of the bases are 3. So if we apply this fact, then our equation becomes 3 to the x is equal to 3 to the 5 times 3 to the 6 divided by 3 to the 4. Awesome. Let's just work on simplifying the right-hand side. So we can make the numerator nicer. That will give us 3 to the 11. Oh, oops. I didn't realize it should have been 3 squared on the bottom. My bad. Fix that now. 3 to the 11 divided by 3 squared. And now we have 3 to the x is equal to 3 to the 9 again. We're canceling factors of 3. So I guess a note is that this 3 to the 9 comes from 3 to the 11 minus 2. Now x is equal to 9. Awesome. So equation 2 was actually really straightforward. Now the bonus, I think, is much harder than both 1 and 2. I'm going to leave it for you guys to do for homework. But again, the hint is to try to write everything under the same base. So right now, the current numbers that we have to deal with are 2, 8, and 32, really. So we have, for instance, powers of 2 here. We have powers of 8, and we also have powers of 32. Well, luckily for us, though, 8 can also be written as 2 cubed, and 32 can also be written as 2 to the 5th. So I would substitute 2 to the 5th in for 32, and 2 cubed in for 8, and try to solve from there. So I'll leave the rest to you guys. Alright, I'll stay on this page for a couple more seconds if you want to take a look. Alright, let's move on to the last page. So I think the last page was the easiest page. I would hope so. The questions are a bit shorter. So in this video, I'll work out questions 1, 3, and 4, and the rest I'll leave for homework. Okay, the first two questions are about scientific notation. So we're given this number, and it kind of looks like it's in scientific notation, but it's not quite, because we have this 528 here, and 528 is definitely not between 1 and 10. Alright, so actually what I'm going to do first is write 528 in scientific notation. So 528 is actually 5.28 times 10 squared in scientific notation. And luckily this isn't too hard to verify. So now if we have 528 times 10 squared, we get 5.28 times 10 squared times 10 squared. And that's 5.28 times 10 to the 4th. This is, in fact, in scientific notation. Some of you might be thinking, well, a second way to do this question, I'll just say an alternate solution, is I can just rewrite 528 times 10 squared as 52800, and then just try to put this whole number in scientific notation. So this now becomes 5.28 times 10 to the 4. This is correct, but it doesn't work well for bigger numbers. So imagine I gave you something like 528 times 10 to the 20 instead of 10 squared. This alternate approach would be very prone to errors, whereas this one is way less prone to error. So number 2 I'm going to skip. It's a really similar problem. Number 3, I gave the hint that remember 0 is an integer. And let's just think about what absolute value really means. Absolute value is measuring the distance on the number line between your number and 0. So let's say I have 0 on my number line here. I'll erase the hint for a second to make some more space. So we have some positive numbers, integers, to the right of 0, and we have negative integers to the left. Okay, and we want integers such that the distance between x and that, or between x and 0, is smaller than 4. And we don't include 4. So this is not including numbers where absolute value equals 4. So this already tells us that we can rule out plus 4 and minus 4. We can also rule out anything to the right of positive 4 because that's just going to be farther away. And similarly, we can rule out anything to the left of minus 4 because that's also going to be farther away. But every integer in between, we can check that the distance to 0 is 1, 2, 3, or 0, which is great. So this tells us that we have to list minus 3, minus 2, minus 1, 0, 1, 2, and 3. So hopefully straightforward enough. Okay, the last question that I'll fully go over is this next one. where we're just simplifying expressions that use absolute value. First things first, I'm just going to put in that number for x. X is equal to 3, so I'll stick that right in. And I'm going to follow PEMDAS. And remember, when we see absolute value signs with an expression in the middle, we're going to treat them like parentheses. So I'm going to do 3 minus 7 first. That's minus 4. Now I can take the absolute value. So the absolute value of minus 4 is 4. But we keep the same number, the same magnitude, but we're chopping off the sign. We don't touch the minus 10 at all. And now I'm going to also just keep using PEMDAS. So I'm going to take 4 minus 10, that's minus 6. And minus 6, that's 6. Another way you could have done this is using the distributive property and distributed the minus sign. We talked a little bit about that last week. That would give us minus 4 plus 10. Again, we can rewrite that as 10 minus 4, which is also 6. So there we have it. Again, this next expression, it's very similar to number 3. Okay, but it's slightly more long of an expression. So again, my tip is just to do, try to do just 1 or 2 simplifications in each step. Right. And very lastly, the bonus I'm going to still give for homework. I will give one hint that this statement is sometimes false. So the directions say, if the statement isn't always true, we want an example that makes the statement false. So I want you guys to find A and B that makes this equation false. Awesome, so that was the whole quiz. Feel free to contact me if you have any questions. So just to recap, we have a couple of red circled questions that you're doing for homework. Number 2, it was really similar to number 1. Maybe some more simplifications are needed, but the same strategies will work. We also have this bonus that relies on the distributive property, and it's good practice. In the next page, we have 2 equations to solve. This one I've done most of the way, but you have to prime factor. And this one, I gave you guys a hint to substitute 2 cubed in for 8, and to substitute 2 to the 5th in for 32. On the very last page, we have a quick exercise on the scientific notation, and we have a quick exercise on absolute values. And this bonus where I want you guys to come up with an example for values of A and B. Okay, that's it for this video. I guess stay tuned for the fun Pi Day video to come.